Hello, beautiful people. Holy cow. Those who are listening, welcome. This is your last unit of the semester, of the year. Let's do it. It's 4 days, and then we will be reviewing for that final. So holy cow, what a year it has been. So let's talk about it. So first, we did these lines, okay? So we made lines, rise and run, all the good stuff. And then we said, you know what? You rock stars, you can do this. This is absolute value. So just doing y equals x. Let's just take a trip down memory lane just for a sec. So y equals x, and then we did y equals absolute value x. And then we were like, you know what, rock stars? Let's do this loop-to-loop, and it's a parabola. What? So y equals x squared. If you're listening, this is Mrs. Robinson in the N Hall N3. Holla, I'm back for another video. All right, so we did a line, and then we did an absolute value, and then we did a quadratic, and now what? This is called an exponential. Say what? This has literally been our year, all right? Especially last year. So we're going to be doing exponential functions. What does that mean? The exponent is the x. Say what now? Okay. So a line to a v to a quadratic x squared, and now the x is the actual exponent. So holy mama, that's why it looks like a roller coaster. Zooming up. All right. So let's fill this out and get this year done ski. Woo! All right, exponential growth function. A function is a growth function if the base is greater than 1. If the base, we're talking about this, that's the base, okay? If the base would be 1, well, 1 squared is 1. 1 to the third is 1. It wouldn't do anything. It would just be a flat line, okay? So the base has to be greater than 1 in order for it to be a growth, okay? The graph will increase from left to right. So it'll go zoom from left to right. Okay, an asymptote. Haha. Asymptote. So what is that? It's a boundary that the graph cannot cross or touch. Okay, so think it's like, you shall not pass, my Lord of the Rings people. So it's something that the graph cannot touch, or the graph will not work, okay? So it's just going to kind of skim along the surface, but never touch it. Okay, in an exponential function, h, oh, that sounds familiar, gives the vertical, oh wait, no, the horizontal asymptote. Hey, look at that. Horizontal, meow, 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 meow. Horizontal, horizon, guys. It goes straight across. Okay? So that is this guy right there. Okay, it's going to tell me what the horizontal asymptote is. All right, let's get into it and actually graph some of these and see what's up. So what are we doing with these x values? Well, they're going to be the exponent, okay? So if y equals b to the x when b equals 3. So what I'm going to do is 3 to the negative third, 3 to the negative second, 3 to the negative first, 3 to the 0, and keep writing for those of you who like to skip ahead and write things down. All right, 3 to the negative third. So what I'm going to do is I'm actually going to start right smack in the middle. Anything with the power of 0 is 1. 3 to the 0 is 1. Now, why is that? Because I have to multiply it. 3 to the first is 3. Why? Because you're actually multiplying by 3. What if I multiply by 3 again? Well, that would be 9. 3 squared is 9. And then again, if I times it by 3, I get 27. Now, what if instead of multiplying something, I'm going to divide something to go the opposite way, okay? So instead of 3 to the first being 3, 3 to the negative first is 1/3, okay? Because I drop it down. I drop it down because it's a negative. Same with 3 to the negative second is 1/9. 3 to the negative third is 1/27. So if you notice the pattern, it's the reciprocal of the actual power. So 3 to the third is 27. 3 to the negative third is 1 over 27. So now you can write all of these numbers into your table, and we can graph them. So negative 3 and 1 to the 27. So I'm going to go over negative 3 and just go right above it. Now I'm going to go, oh wait, that was, yeah. All right, keep on trucking. So let's try the next one. Negative 2, 1/9. So negative 2 up 1/9. Negative 1 up 1/3. So again, it's just skimming across the surface. 0, 1. So we go here. So if you notice, it goes skim across the surface, and then it's going to go super fast. And then 1 to the 1 over 1 and up 3. 1, 2, 3. And then over 2 and up 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, and then 327, I can't graph that one. So if you notice, this is what happened with our lovely virus that we keep talking about. So, and people say it's exponential. It started off really, really slow, and then the more people who got infected, it just shot off like a rocket. Okay, so that's what happens. It's an exponential function. Again, it starts off slow and then goes up fast. Okay, so notice that the graph increases, right? Holy mama, it increases. Okay, it makes a curve. Okay, all right, the x-axis is an asymptote of the graph. Why? Because it was just b to the x. So x equals 0. So I'm going to draw a dotted line at the 0. That's called an asymptote, meaning, again, it cannot cross it. Okay, the domain of the parent function is all real numbers. Okay, depending on your teacher, I like to write an R and put an extra line in it. Your teacher might also go negative infinity to infinity, meaning that everything works for it. Okay, and then the range of the parent function. This is very important. Does it cross? Is there any y values down here? I don't see any y values. And again, it cannot touch the 0. So the range is y is greater than 0, not equal to, just greater than. Okay, because again, it cannot touch the 0. So all my y values are above 0. Okay, all right, let's try another one. Oh, the step, sorry. So step 1, identify the base of the function. So you might have something like y equals a times b to the x. So you need to identify what is attached. Okay, the base. You got to find the base of the function. Okay, also known as the b for base. Okay, it is attached to the exponent. I keep saying the same thing over and over. All right, find your crucial points using, well, -1, 0, and 1. This will give you a good indication of what it looks like on both sides of the graph, right? So if I can graph these 3 points, I can kind of see where it's curving. All right, step 3, plot the crucial points. All right, sketch the exponential function. So your graph should even look like this, which is a growth. And then tomorrow you're going to talk about, or the next video, you're going to talk about decay. I know, guys, these videos are exhausting. We feel the same way. Just get them done, and let's get this show on the road. All right, it's kind of how we all feel right now. All right, so number 1, y equals 2 to the x. Well, b is 2, right? So I want to graph these crucial points. So I'm going to do 2 to the -1, 2 to the 0, and 2 to the first, and graph these crucial points. So 2 to the -1, it's the reciprocal, guys. It's 1/2. 2 to the 0, anything to the 0 power is 1. And then 2 to the first is 2. So I'm going to graph those points and see what's up. So -1 and 1/2, up 1/2. 0, 1, and then 1, 2, over 1, up 2. And again, I should be making a curve. Whoop! All righty. And then it says domain. Again, domain is all real numbers. X, I can plug anything in for X. It's just hard to see over here because it's going to be way up here because it's exponential. Again, that roller coaster when you're going all the way to the top of it. All right, and then the range. What is the range? Well, there's nothing attached to x, so that means that my asymptote, boop, 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 is x equals 0. So there's no y values smaller than 0. So y is greater than 0. All right, I want you to try this one. 4 to the negative 1, 4 to the 0, and 4 to the 1. I want you guys to try that one out. Woohoo! So try those points out, graph it, and see if you can figure out the domain and range. And that's what you should have gotten for number 2. The base is 4. 4 to the negative 1 is 1/4. 4 to the 0 is 1. And 4 to the first is 4. Okay? The domain is all real numbers. The range is still y is greater than 0. There's nothing smaller. You cannot touch the 0. Okay? All right, the next two. Now, how is this different? Well, there's a number in front of it. The starting point is different for 3 and 4. So that's a little different than 1 and 2. So how does that change? Okay, so we got to plot those points. We got to still plot those crucial points, but now we have it times something. All right, so we first need to figure out, we got to times this, and then we're going to times it by 3. Okay, so I'm going to do 2 to the negative 1. 2 to the 0, and 2 to the first. So we're still going to do the same song and dance, but then I have to times it by 3, okay? So 2 to the negative first is 1/2, 2 to the 0 is 1, and 2 to the first is 2. Then I'm going to times each of these numbers by that number in front. So I'm going to times each of these numbers by 3. Okay, so 3 times 1/2 is 3/2. Which is 1.5. 3 times 1 is 3. And 3 times 2 is 6. So what it did is it kind of just moved it up a bit. And we can see that from here. All right, so negative 1 and 3/2. So negative 1 up 1.5. That's 3/2 is 1.5. Okay? 0, 3, 1, 2, 3. Oh, look at that. So instead of it being at the 1, it's going to be at the 3. And then 1, 6. Over 1 up 6. 1, 2, 3, 4, 5, 6. Okay? We still have a curve. It's still a growth. Whoop. It's just moved up a bit. Okay? Again, the asymptote is still at the 0. Okay? There is no h there, so it's 0. Domain is all real numbers. Range is y is greater than 0. That's still the case. Okay? For 5 and 6, it'll be a little different. All right. So please don't multiply these together and then do the exponent. The base is 2. Not 3 times 2, all right? The same for this one, 4 to the x. So 4 to the negative 1, 4 to the 0, and 4 to the first. That's my first step. I'm going to do the base. So 4 to the negative first is 1/4. 4 to the 0 is 1, and 4 to the first is 4. Now I'm going to times that by the negative 1/2 in front. All right, so negative 1/2 times 1/4 is negative 1/8. Okay? Whoa, mama. Okay? And then 1 times negative 1/2 is negative 1/2. And 4 times negative 1/2, well, that would be negative 4 over 2. And that would be negative 2. So this negative in front changes these y values. Do you guys notice that? Okay, so what's going to happen? Let's graph it. Negative 1 and negative 1/8. So I'm going to go over negative 1 and down a smidgen to get negative 1/8. I'm going to go to 0, and then it's going to be a little bit more. So I know kind of these graphs are just ish. Just do your best, guys. And then 1, negative 2, over 1 and down 2. So my curve is this way. So instead of it going up, so this is a growth, right? But this negative in front makes it a reflection, okay? So what used to happen, we just did quadratics, guys, and sometimes it opened down instead of up. That's the same thing with this, guys. If there's a negative for that, we drop it down. Not a negative exponent, a negative a in front. All right, so domain is all real numbers still, but what happens to the range? Well, my asymptote is still at the 0, but there's no y values up here. So the range is y is less than 0 instead of y is greater than 0. Because again, all your y values are right below the 0. Whew. Okay, so just be aware of where the negatives are and how that affects it. All right, we've got 2 more, guys, and then we are done. Okay. So how are we going to do this one? So, holy guacamole pants, there's something here. Okay, so let's remind ourselves, when I have x minus h plus k, what on earth does that mean? So this means left or right, and the k is telling me to go up or down. The same thing applies when it's an exponent. This is my h. Well, it's the opposite, so this means right 3. And what does the plus 1 mean? That means what it means. Plus 1, up 1. Okay, so what I'm going to do is I'm going to change my origin. What? I'm going to call it the transformation origin. So I'm going to go over 3, 1, 2, 3, and up 1. Meow, meow. This is going to be my new point based on this information, right? 3, up 1. And I'm going to do my critical points as usual by using my base. My base is 2. So 2 to the negative 1, 2 to the 0, and 2 to the 1. Just stay with me and it will make sense, I hope. All right. 2 to the negative 1 is 1/2. Remember, drop it down to the denominator. 2 to the 0 is 1, and 2 to the first is 2. All right, all right. So this is my new transformation based on right 3, up 1. Why didn't we have to do that for the other ones? Well, if you notice, there was nothing attached to the exponent or the extra number. There was no plus or minus for these. But now we have that for 5 and 6. All right? So that's why we got to do this fancy danciness. So from this part, not from here, I'm going to go negative 1 up to 1/2. And I'm going to go 0, 1 from that new transformation. And then over 1 and up 2. Say what? And this is my graph at this point. Mamma mia. All right. Domain is still all real numbers. You're going to get points for all of these. Now, how is the range changed? All right, guys. Let's think about this. So this plus 1, okay, that actually tells me what the asymptote is. Holy guacamole. All right, you guys have to head back to your notes. It's not the H, it's the K. Oh, geez. Sorry about ya. What? Miss Robinson. Getting it together. All right, the K. Holy mama. Of course the K tells us what to do. The K is telling me what the asymptote is. Oh, geez, Louise. The K. All right, so the K tells us what to do. So the K is plus 1. So my asymptote is at x equals 1. So it cannot cross the 1. All right, so asymptote is your K. Your K is the plus or minus. If there's nothing there, it's 0. So your K is 1, therefore your asymptote is 1. What does that do? Well, that affects the range. Okay, so instead of it being y is greater than 0, is y is greater than 1. Y is greater than 1. All right. Whew. Now, one more. So what does this plus 1 mean? Well, this minus 3 meant right, so plus must mean left 1. And what does minus 3 mean? Well, this means up, so this must mean down. So I'm going to go left 1 and down 3. 1, 2, 3, and make my new transformation origin. Okay? What is my base? My base is 4, so 4 to the negative 1, 4 to the 0, and 4 to the 1. So 4 to the negative 1 is 1/4. Again, there's no negative a part of it. It just makes it into a fraction. Drop it down to the denominator. 4 to the 0 is 1, and 4 to the first is 4. All right, I'm not going to graph these here. I'm going to graph it from this point. So negative 1, 4. So I'm going to go negative 1 up 4. 0, 1. And then 1, 4. Over 1, 1, 2, 3, 4. Okay? So it moved over. So the whole curve moved over to that point. Domain is all real numbers. Again, let's think about the range. The range is the K. And there was nothing there for these. Okay, that's why it was 0. There was no plus or minus. This one is minus 3. So your asymptote is 3, negative 3. Okay? So, boop, 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 it cannot cross this. So it moved the whole thing down. So it also moved the range down. So range is y is greater than negative 3. Okay? It's everything above 3. So that's your starting point, and then you went above it. All right? So thanks so much for joining me on day 1. Day 2 will be now doing the decay. So it'll start up high and then decrease below. All right? And then we will be doing some applications. All right, guys, you're doing great. Keep it up. Let's get to this end of the year. Bye.